The darkness that the human eye has never known unfolds under the wing of the Orion spacecraft. The Artemis II mission is performing a historical maneuver, rounding the far side of the moon. Here, in the radio shadow of Earth, astronauts remain alone with the abyss. What they see in the starlight is not aliens or cities, but this sight terrifies with its scale. A mangled landscape, giant craters, and anomalies that challenge our understanding of the evolution of the solar system. Today, we will reveal the scientific truth about what the eternal night of our satellite conceals. For thousands of years, humanity looked at the night sky, seeing only one side of our natural satellite. This frozen face of the moon, covered with dark spots, gave birth to countless myths, legends, and calendar systems. However, what was hidden beyond the limit of visibility remained the greatest mystery of our planet. Why do we see only one side? This is not an accident or a cosmic conspiracy, but the result of a fundamental physical process that scientists call tidal locking. Right where you are watching from, it is interesting to see how far our stories spread. Like and subscribe. We are beginning. The gravity of Earth for billions of years acted on the moon like an invisible brake. When the moon was still young, hot, and plastic, terrestrial gravity created tidal bulges on it. Gradually, the rotational energy of the satellite was spent on overcoming this friction until its period of rotation around its own axis coincided with the period of rotation around our planet. This is exactly why we are forever chained by our gaze to only one of its hemispheres. But it was precisely this invisibility that gave birth to that primal fear of the unknown, which today, in the 21st century, is transforming into scientific awe before the data sent by the Artemis II mission. The true story of the exploration of the dark side, although it is more accurate to call it the reverse side, as it receives as much sunlight as the visible side, began at the height of the Cold War. In October 1959, the Soviet automatic interplanetary station Luna 3 did what was previously considered impossible. It rounded the satellite and took the first grainy, extremely low-quality photographs of what was hidden behind the horizon. When these frames were developed, scientists all over the world felt a real shock. It was not just another face of the moon. It was a different world. If the visible side was covered with large dark plains that we call seas, frozen basins of ancient lava, the reverse side turned out to be a mangled, chaotic desert of endless craters. There were almost no seas there. It looked as if the moon used itself as a living shield, taking on billions of asteroid strikes that could have destroyed life on Earth. This asymmetry, the lunar dichotomy, became one of the greatest mysteries of modern astrophysics. Why is this topic so important right now? Because the Artemis II mission is not just a flight around the moon. It is the first return of humans to these coordinates in the last 50 years, but with equipment that is millions of times more powerful than the technologies of the past. Astronauts on board the Orion spacecraft are equipped with multispectral cameras and lidars capable of peering into the depth of the regolith. When the crew passes over the far side, they enter a zone of total radio silence. All the noise of our civilization, radio, television, the internet, cellular signals, is completely blocked by the mass of the moon. This place is the quietest in the known universe for radio observations, and it is in this silence that the instruments of Orion began to record what made the researchers at the Mission Control Center in Houston hold their breath. We are used to thinking of the moon as a dead stone, but geological data suggests the opposite. Scientists from the National Aeronautics and Space Administration, analyzing previous data from the Lunar Reconnaissance Orbiter, pointed to strange thermal activity in certain craters of the far side. What Artemis II observes directly confirms. Processes are occurring under the mangled crust that we still cannot fully explain. Imagine. You are at an altitude of only a few dozen kilometers above the surface, where there has never been sunlight in the deep abysses of the craters. Your sensors record not just stones, but structures resembling giant glassy formations that arose as a result of incredible temperatures. These are not traces of civilizations. These are traces of cosmic catastrophes of such a scale that they go beyond human imagination. Every crater on the reverse side is a scar from an impact that could have evaporated the oceans on Earth. Today, we understand that the far side of the Moon is a chronicle of the late heavy bombardment, a period about 4 billion years ago when the solar system was a real shooting gallery. The study of these terrifying landscapes allows us to understand what our own planet went through. Without the Moon and its ability to absorb these impacts, the evolution of life on Earth might never have occurred or would have been interrupted at its very inception. But there is something else. Data from the Artemis II mission indicates that the gravitational field over certain regions of the far side behaves abnormally. The crust there is much thicker than on the visible side, and it hides giant massifs of dense matter underneath. What is this? Remnants of ancient protoplanets that crashed into the Moon billions of years ago? Or something that will force us to completely rewrite the textbooks of planetary science? We are only beginning to realize that the horror spoken of in the context of the reverse side is not a fear of monsters, but an existential awe before the greatness of cosmic chaos of which we are a part. The Artemis II mission opens the door into this abyss, and what we see there will forever change our place in the universe. After the completion of the Apollo era in 1972, the Moon ceased to be a priority for manned cosmonautics for long decades. However, at the beginning of the 21st century, scientific interest flared up with new force. This period is often called the second lunar race. But this time, its goal is not just planting a flag, but a deep scientific justification for the presence of humans and the disclosure of secrets that the satellite kept for billions of years. A key moment in the study of specifically the far side was a mission that forever changed our understanding of the accessibility of this region. On January 3, 2019, the Chinese automatic interplanetary station Chang'e 4 performed the first soft landing in human history on the far side of the Moon. The landing site was the von Karman crater, located in the giant South Pole Aitken Basin. This achievement was technically difficult due to the lack of direct visibility of Earth, which required the use of the Queqiao relay satellite placed at the Lagrange Point 2. The U-22 rover, operating within this mission, provided the scientific community with priceless data. Its panoramic cameras and ground-penetrating radar revealed that the structure of the regolith on the reverse side significantly differs from what we saw at the landing sites of the American Apollo missions. Analysis showed the presence of materials that could have been brought up from the upper mantle of the Moon as a result of ancient, powerful impacts. This discovery confirmed the theory that the far side is a true geological archive of the early solar system. In parallel with these successes, the National Aeronautics and Space Administration began developing the Artemis program. Unlike its predecessors, this program is based on international cooperation involving the European Space Agency, the Japan Aerospace Exploration Agency, and other partners. The main tool for realizing this ambitious goal was the Space Launch System, the most powerful launch vehicle of modern times, capable of sending the Orion spacecraft on a trajectory to the Moon. Preparation for the Artemis II mission lasted more than a decade. The Orion spacecraft was designed to ensure the life support of 4 astronauts during the flight, which will last about 10 days. Its service module, provided by the European Space Agency, is responsible for power supply and maneuvering. One of the most difficult stages of preparation was calculating the free return trajectory. This is a path that allows the spacecraft to round the Moon using its gravity and return to Earth without the need to use the main engine in case of unforeseen circumstances. Why does this flight cause such awe among scientists? Because the crew of Artemis II will become the first humans to see the far side of the Moon with their own eyes since the time of the Apollo 17 mission. But they will be equipped with spectrometers and instruments for measuring the radiation background that will work in real time. Particular attention is paid to the study of abnormally low temperatures in regions that are in permanent shadow. According to data from scientific journals such as Nature, previous remote studies indicated that on the reverse side, The concentration of certain isotopes, for example, helium-3, may be higher. This is a potential fuel for the nuclear fusion of the future. Thus, the historical context smoothly passes into a practical plane. We study the past of the Moon to build the energy future of Earth. The Artemis II mission is a logical continuation of the unmanned Artemis I mission, which in 2022 confirmed the reliability of the Orion spacecraft during a flight to a high circumlunar orbit. Now, when there will be people inside the cabin, every maneuver takes on special significance. Passing over the far side at an altitude of only about 10,300 kilometers will allow astronauts to observe landscape details that were previously available only to automatic probes. This stage of the mission is not just a flight. It is a psychological and technical boundary. When the spacecraft disappears behind the lunar limb and communication with Earth is interrupted for 30 to 40 minutes, the moment of truth arrives. In these minutes, the astronauts face absolute loneliness in space, observing craters that only a few in the history of our species have seen. This is a return to the primary sources, to the moment when humans first understood how small their home is compared to the boundless emptiness. The development of technology and the accumulated experience of previous decades allow us today not just to look at the reverse side, but also to understand the physics of the processes occurring there. From thermal cycles, where the temperature fluctuates from -170 to +120 degrees Celsius, to bombardment by solar wind, from which nothing protects this side. This background creates a foundation for the next stage of our journey. A deep scientific analysis of those horrors and anomalies that the instruments recorded during this historical flyby. When we move from history to the direct analysis of data obtained by modern instruments, a picture emerges that is striking in its scale and severity. The largest geological structure on the far side of the Moon, which captured the attention of the Artemis II mission crew, is the South Pole Aitken Basin. This is not just a crater in the usual sense. It is a colossal dent about 2,500 kilometers in diameter, covering almost a quarter of the circumference of the satellite. Its depth reaches 13 kilometers, making this basin the deepest and oldest impact structure in the entire solar system. The scientific importance of this region lies in the fact that the impact that created it billions of years ago was so powerful that it literally pierced the lunar crust, exposing layers of the upper mantle. Data from spectrometers installed on board the Lunar Reconnaissance Orbiter confirm the presence of a large amount of olivine and pyroxene, minerals that are usually found deep below the surface. For scientists, this means the possibility of studying the insides of another cosmic body without resorting to drilling to a depth of many kilometers. Every rock, every handful of regolith in this basin is the primary substance from which the Moon was formed. However, real scientific shock was caused by data obtained in the course of the Gravity Recovery and Interior Laboratory mission, known by the abbreviation GRAIL. It turned out that under the bottom of the South Pole Aitken Basin, an abnormally large mass of dense substance is hidden. Research conducted by scientists from Baylor University showed that at a depth of about 300 kilometers, there is an object whose mass is approximately 2 quintillion kilograms. This can be compared to a metallic island that is 5 times larger than the territory of the Big Island of Hawaii. The scientific explanation of this phenomenon is simultaneously fascinating and frightening. Most likely, these are the remains of the metallic core of a giant asteroid that crashed into the Moon about 4,100,000,000 years ago. Instead of evaporating or dissolving in the mantle, this metal remained trapped in the depths of the satellite, creating a powerful gravitational anomaly. Artemis II astronauts flying over this region are under the influence of this invisible force, which literally pulls the spacecraft to the surface slightly harder than at any other point. These gravitational anomalies, known in science as mascons, mass concentrations, are a real challenge for navigation. They make the gravitational field of the Moon uneven and lumpy. Without precise calculations based on data from the National Aeronautics and Space Administration, the orbit of any apparatus over the reverse side would quickly degrade, which would lead to an inevitable crash. What we see on gravity maps resembles internal scars from a catastrophic collision that almost tore the moon apart. In addition to gravity, Orion instruments record sharp drops in magnetic fields. Unlike Earth, the moon does not have a global magnetic field. However, on the reverse side, there are local magnetic spots. Some scientists suggest that these are magnetized fragments of that same killer asteroid. These zones create peculiar mini-magnetospheres that deflect the solar wind, creating bizarre patterns on the surface known as lunar swirls. These bright stripes against the background of dark regolith look like ghostly prints on the landscape, which once again emphasizes the complexity of physical processes in this zone of eternal shadow. Analysis of data from the Lunar Reconnaissance Orbiter also revealed an unexpectedly high concentration of thorium and other radioactive elements in certain points of the far side. This poses a new question for science. How were these elements distributed during the formation of the satellite? If the visible side was flooded with lava that brought these elements to the surface, why are they concentrated in individual nodes on the reverse side? For the crew of Artemis II, observing these anomalies is not just a matter of gathering statistics. It is an attempt to understand the dynamics of planetary catastrophes. Every sensor, every LiDAR pulse reflecting from the bottom of the Apollo crater or the Schrödinger basin adds a detail to the map of an object that we are only now beginning to truly see. What previously seemed like horror due to the unknown now becomes horror due to the realization of the colossal energy of the impacts that formed this world. We are looking at the results of physical processes, the scale of which is difficult to grasp with the human mind, but which are recorded in every millimeter of the lunar crust. One of the most difficult puzzles that scientists are trying to solve using data from the Artemis II mission is the so-called asymmetry of the lunar crust. When we compare the two hemispheres of our satellite, the difference is striking even on a chemical level. The visible side is covered with dark basaltic seas, which occupy about 31% of its surface. In contrast, on the far side, these volcanic plains make up only 1%. This creates an illusion of two different celestial bodies sewn together. The scientific explanation of this phenomenon, published in the journal Nature, is based on models of early satellite formation. Shortly after its birth, about 4,500,000,000 years ago, the moon was an ocean of molten magma. Since it was extremely close to Earth, which at that time was a red-hot ball with a temperature of over 2,500 degrees Celsius, the radiation of our planet did not allow the near side of the moon to cool down quickly. The reverse side, turned toward cold space, cooled much faster. This led to the fact that aluminum and calcium condensed in the atmosphere of the early moon and fell as snow on the far side, creating a much thicker and stronger crust there. This difference in crust thickness, from 30 kilometers on the visible side to 60 or even 100 kilometers on the reverse side, explains why we do not see large seas there. Asteroids that crashed into the reverse side simply did not have enough energy to pierce the thick layer of rock and release internal lava. LiDARs of the Orion spacecraft confirm this structural strength, demonstrating a relief that has preserved the traces of bombardments that occurred billions of years ago. However, besides geological anomalies, the far side of the moon hides what scientists call the greatest treasure for astronomy. This is radio silence. Earth is an extremely loud planet. Thousands of satellites, billions of mobile phones, and television towers create a powerful electromagnetic background. For sensitive radio telescopes, this is like trying to hear a whisper against the background of the roar of a jet engine. The mass of the moon acts as a giant screen 3,474 kilometers thick, which completely blocks terrestrial interference. Experts from the National Aeronautics and Space Administration emphasize that it is precisely here, on the far side, that humanity will finally be able to see the dark ages of the universe, the period before the formation of the first stars. At this time, neutral hydrogen radiated at very low frequencies that cannot be recorded from Earth due to interference and the ionosphere. The Lunar Surface Electromagnetics Experiment Project, which is being developed jointly with the Brookhaven National Laboratory, aims to place antenna arrays on the far side that will become the ears of humanity in the deepest silence of the solar system. Artemis II astronauts recorded unique conditions in the radio silence zone. When the spacecraft is behind the moon, it enters a state of total informational isolation. At this moment, the only source of signals becomes distant pulsars, quasars, and cosmic microwave background radiation. This is not just a technical aspect. It is an opportunity to explore the nature of spacetime itself without anthropogenic noise. What may seem like a terrifying void is actually the cleanest window into space. During the analysis of the far-side regolith conducted by remote instruments, scientists also paid attention to unusual isotopic signatures. The iron content on the far side is significantly lower than on the visible side. This again brings us back to the big impact hypothesis. If the moon was formed from debris after the impact of the planet Theia against Earth, then the distribution of substance should have been chaotic. But the clear asymmetry that we observe now forces physicists to review mathematical models of how gravity and heat flows interacted in the first millions of years of the existence of the Earth-Moon system. Thus, the scientific base of the far side is built on three pillars: the extreme thickness of the crust, gravitational mascons, and ideal radio silence. Each of these factors makes this region not just the other side, but a key to understanding how rocky planets are formed. The Artemis II mission provides direct evidence that the moon is not a static object, but a dynamic system whose history is written in its landscape. The study of these anomalies allows us not only to peer into the past, but also to prepare a platform for the next step: the creation of permanent scientific bases that will use the unique physical properties of the far side for a breakthrough in cosmology and fundamental physics. When we analyze data collected by the Artemis II mission, we inevitably face a fundamental question. Where did the moon come from, and why is its far side so different from the visible one? Generally accepted in the scientific community is the big impact hypothesis. According to this theory, approximately 4,500,000,000 years ago, a protoplanet the size of Mars, which scientists named Theia, crashed into the young Earth. As a result of this colossal impact, a huge amount of substance from both bodies was ejected into near-Earth orbit, where over time, under the action of gravity, the moon was formed. However, data on the extreme thickness of the crust on the far side forced some scientists to put forward alternative, even more ambitious versions. One of them, published in the journal Nature, is known as the second moon hypothesis. Astrophysicists Eric Asfaug and Martin Utzi suggested that after the collision with Theia, two satellites could have formed around Earth. For tens of millions of years, they revolved in a common orbit until the smaller satellite, about 1,200 kilometers in diameter, caught up with the larger one. This was not a catastrophic collision that would have led to the formation of a crater. It was a so-called slow collision, where the impact speed was lower than the speed of sound in the rock. Imagine a giant cosmic slap. The smaller satellite literally smeared itself over the surface of the larger one, becoming an additional layer of material. It is precisely this process that could explain why the crust on the far side is 30 to 60 kilometers thicker. What the Artemis II astronauts see as a harsh landscape may be the remains of the second lost satellite of our planet. Another sharp scientific discussion concerns the presence of volatile substances, primarily water ice, in the craters of eternal shadow. For decades, scientists considered the moon an absolutely dry world. However, a mission of the National Aeronautics and Space Administration called L-Cross in 2009 proved the opposite by performing a controlled crash of an upper stage into the Cabeus crater at the South Pole. Analysis of the ejected plume of dust showed the presence of water vapor and ice crystals. Artemis II astronauts, using high-resolution infrared cameras, observe so-called cold traps. These are regions inside deep craters where sunlight has not reached for billions of years. The temperature there stably stays below -230 degrees Celsius. In such conditions, a water molecule that got there as a result of a comet strike remains frozen forever. The scientific community today is conducting debates. How massive are these deposits? Data from the LRO spacecraft indicate that the ice may not just be frost on the surface, but may lie in the form of massive lenses or mix with regolith at a depth of several meters. This discovery is of decisive importance for future colonization. Water is not only for drinking, it is a source of oxygen for breathing and hydrogen for rocket fuel. The moon is transforming before our eyes from a dead stone into a strategic cosmic gas station. Future missions, such as the VIPER lunar rover being developed by the National Aeronautics and Space Administration, aim to drill the lunar soil specifically in these dark zones. Data collected by the Artemis II crew will help determine the most promising points for such exploration. Scientists from the Japan Aerospace Exploration Agency and the European Space Agency also plan their missions to the South Pole Aitken Basin, believing that it is there that the answer is hidden to the question of whether water was brought to Earth and the Moon by comets in the early stages of development. We are standing on the threshold of a paradigm shift. If the hypothesis of a second moon or massive ice deposits is confirmed, we will have to completely reconsider the history of our region of space. What we see on the far side of the moon today is not just an exotic relief. It is a laboratory of fundamental physics waiting for its researchers. Every new report from the Orion crew brings us closer to the moment when we can say with confidence, the moon is not just a satellite, but an integral part of the history of life on Earth that has preserved for us the oldest secrets of our planetary system. The success of the Artemis II mission today is only a prelude to a large-scale expansion of humanity that will unfold in the next 2 decades. The scientific world is already preparing tools that will transform the far side of the moon from an object of observation into a full-fledged scientific platform. One of such key tools already working for the benefit of lunar research is the James Webb Space Telescope. Although its main goal is deep space, its ultra-sensitive infrared sensors are used to calibrate data on the thermal radiation of the lunar regolith. This allows scientists with incredible precision to model how the temperature changes in the craters of eternal shadow, preparing the ground for the landing of robotic explorers. However, a real revolution will occur directly in the orbit of the satellite. The Lunar Gateway project will become the first space station in human history in a circumlunar orbit. This is a joint project of the National Aeronautics and Space Administration, the European Space Agency, the Japan Aerospace Exploration Agency, and the Canadian Space Agency. The station will be placed in a unique, near-rectilinear halo orbit, which will allow it to constantly maintain communication with Earth and at the same time be as close as possible to the south pole of the Moon. Lunar Gateway will perform the role of not only a scientific hub, but also a cosmic port. It will become a transit point for astronauts heading to the surface and for future missions to Mars. Thanks to the low gravity of the Moon, launching ships to a distant planet from its orbit will require significantly less fuel than a start from Earth. For the Artemis II crew, the experience of flying in these latitudes is critically important for testing life support systems that will later be integrated into the station modules. In parallel with orbital plans, the European Space Agency is actively promoting the concept of the lunar village. This is not just one base, but an open international platform where different states and private companies will be able to deploy their modules. The main challenge here is the use of local resources, or in situ resource utilization. Scientists are developing 3-dimensional printing technologies that will allow using lunar dust, regolith, to create protective shells for buildings. This will protect astronauts from harsh cosmic radiation and micrometeorites, which are a constant threat on the far side of the Moon. One of the most ambitious projects mentioned in reports of leading astrophysicists is the construction of a radio telescope in a crater on the far side. The project, called Lunar Crater Radio Telescope, involves deploying a wire mesh using robots inside the natural bowl of a crater with a diameter of 3 to 5 kilometers. Such an instrument will be able to record long radio waves that no telescope on Earth is capable of catching. This will allow us to literally see the cosmos in the state it was in several 100 million years after the Big Bang. Future missions will also focus on studying volcanic caves, so-called lava tubes. These underground tunnels, formed billions of years ago by lava flows, could become an ideal place for placing residential blocks. A stable temperature of about -20 degrees Celsius prevails there, which is much better than the extreme fluctuations on the surface. Data from Artemis II help LiDARs detect entrances to such caves, so-called skylights, which look like perfectly round black holes in the middle of the landscape. An important aspect of future research is also the geopolitical component. The moon is becoming a zone of interest not only for scientists but also for economists. Deposits of rare earth metals and the helium-3 isotope, which we mentioned earlier, can cause a real industrial boom. However, the international community, in particular through the Artemis Accords, is trying to establish clear rules of the game so that the development of the satellite occurs peacefully and for the benefit of all humanity. Thus, the future that Artemis II opens before us is not just short-term visits, but the transformation of the moon into the seventh continent of Earth. This is the path from the first images of the reverse side to the construction of high-tech cities under the surface of the regolith. We are standing on the threshold of a time when children born today will be able to see the first lights of human settlements in the zone of eternal shadow, where previously only cold and silence prevailed. When the Orion spacecraft emerges from the radio silence zone and re-establishes communication with Earth, the crew of the Artemis II mission brings with them not only terabytes of scientific data, but also a new understanding of our fragility. The culmination of our research lies in a change of perspective. What we initially called the horror of the far side of the moon, these crater-mangled wastes, gravitational anomalies, and endless darkness, is actually the highest manifestation of cosmic self-sacrifice. Each of the hundreds of thousands of craters that the astronauts saw under their windows is an impact that could have been aimed at Earth. For 4,500,000,000 years, the moon stood on guard, taking on the strikes of asteroids and comets that carried death. The reverse side of the satellite is the mangled shield of our species. Without this scary and ugly surface, the evolution of life on our planet would have been interrupted at the stage of microorganisms. The true horror is not in what we see there, but in the realization of what our world would be like without this silent protector. This discovery pushes us toward deep philosophical reflections. We are used to considering ourselves the center of the universe, but a flight over the far side of the moon shows us the true scales. We are only a tiny spark of intelligence in an ocean of cold, indifferent stones. However, it is precisely our desire to return there, to understand the nature of mascons, to solve the mystery of the origin of the South Pole Aitken Basin, and to build stations in the zone of eternal shadow that makes us great. Horror turns into awe, and fear into scientific curiosity. The Artemis II mission proves that humanity no longer agrees to just look at the stars from the bottom up. We are returning to the moon not as guests, but as a species that is ready to take responsibility for its cosmic future. The far side of the moon is no longer a territory of mysteries and conspiracy theories. Now it is our new scientific frontier, a source of energy and a window into the deepest past of the universe. What we saw there should not frighten us. It should inspire us to go further, beyond lunar orbit, to Mars, and beyond, into infinity. We have just made a journey to the darkest corners of our satellite, revealing the scientific truth hidden behind the myths. The moon remains our first step to the stars, and every step of the Artemis program brings us closer to the moment when humans become a truly interplanetary species. If you want to continue to be the first to know about the greatest discoveries in astrophysics and cosmonautics, subscribe to our channel and leave a like. Write in the comments, would you be ready to become one of the first residents of a lunar village on the far side? Thank you for exploring the universe with us. Until we meet again in new videos.